Welcome to the course Digital Transformation and Technological Innovation. So, we are into our second module, that is digital infrastructure. So, let us start from where we left in the last session. So, we were talking about how should computer hardware and software components should be selected to support the organization's information systems, and we have covered the hardware part, so many different aspects of computer hardware and different decision points that would be important, technical and non-technical. So, we covered all that in last few sessions. Right now, we move towards the software component of this question. So, essentially the main idea remains same, that selection has to be guided by efficient processing and timely output. So, that is the important goal for an organization, so that they are able to meet their business objectives, right. So, computer hardware and software should be acquired in such a manner that they support organization information systems for efficient processing and timely output. Now the question again, how to select the right computer software, right. So, again, just like in the case of hardware, the link we need to understand. In case of hardware, it was the link between the hardware and the computing needs. Now, in the case of software, we are just making small change, that we are saying understanding the link to the processing needs. So, from computing to processing, because when it comes to software, we input real data, real information, and that is to be processed as per the logic that is embedded in the software. So, it is better to say processing needs of information systems in case of a software, and in case of a hardware we can say the computing need, because that infra has to support the computing that would be needed by the information system. So, from computing need in case of a hardware to processing need in case of a software. So, that link we need to understand. Then current and future business needs, this point remains same, that whatever be the information systems for the organization, we should be able to acquire the computer hardware and software which can be used to support or cater to the current and future business needs, right, in general. So, move on. So, now if we look at IT spending and how it is getting distributed to the software component and the hardware component. So, if we look at the data, we typically observe that IT spending on software, it exceeds that on the hardware. So, that also that is understandable, that is natural, because as an organization is moving towards more digital way of doing things, we are in the information era, and we have to use information technology and other digital infrastructure and everything, so that most of the business activities we are able to automate or support through digital technologies. So, because in that process software plays a main role, because the kind of varied processing needs that an organization can do, it might change, and there might be additional realization in terms of what other processes can also be digitized or can be supported through a software and information systems, right. So, because of that, it is likely that spending on software is on the higher side. Second reason is software are updated and new versions are released, while a hardware, once you buy them, so the upfront cost is high, but they live for a certain number of years, while so it's like one time you buy and hopefully they will be there for, let us say, 10 years, 5 years, 10 years, or maybe more. But in case of a software, there would be new versions that will be released from time to time, maybe within 2 years, even in the case of enterprise software, sometimes within 1 year, right. So, to be able to get those updates and get the support, organizations, enterprises might end up paying more, and therefore IT spending in general is likely to be higher for the software than in case of a hardware. Now, so essentially what are these spending? So, if we look at generic subcategories here, so updated software and services, to be able to keep the software and services updated, so there the spending will go. Then IT outsourcing and managed services, we might be taking the cloud services, or we might be outsourcing part of or full software development to some tech company. So, there it will go. And then if we talk about IT and business consulting, so IT and business consulting is a mixed thing, that this consulting might be on hardware side or on the software side or both of it. So, therefore, it can be considered in the both the brackets, like software and hardware. Then so the first two for the software, then this is like mixed both IT and business consulting. Then we can talk about the these two, IT hardware and infra communication network equipment. So, this will mostly go to the hardware part, right, hopefully. So, so this is the kind of distribution we are talking about. So, what I did, I used generative AI apps and I tried to fetch some data through these apps as to what are the likely percentages. So, this is more like we can take this data at an illustrative level, right, but it could be closer to the reality. Hopefully, the generative AI was true to this data that we have here. So, if we look at this data, so you can see the same thing that we hoped we will see. Updated software and services, the largest component, which is closely followed by, not closely, but second place is IT outsourcing and managed services, and then we have IT hardware and infra part, that is here. Then IT and business consulting, that is here, which is mix. So, this one is mix for both in a way we can say. Then communication network is here. So, you can see communication and network, this is the hardware axis, right. This is IT hardware infrastructure and communication and network equipment. This is more like a hardware axis and this is more like a software axis, and this is more likely consulting can be on both these components, whether the hardware or the software. So, this is the overall picture in terms of IT spending. So, this gives us a fair idea about what is happening at a higher level across industries. Now, moving on, now let us go through some of the definitions, terminology here. So, what is a software program, right? So, a brief concise definition of software program is a sequence of instructions for the computer. So, a software program is holding or containing some logic which is connected to the business process, the steps that need to be executed. So, essentially that code or the logic that is represented in the form of code or these instructions, right, that are to be executed by the computer, right. And there could be mathematical operation, logic operations, or maybe data related operations. So, all those instructions, and in a particular sequence of those instructions, they will put together be a program which will be catering to something, some business process, some logic, or some simple task, right, or activity. So, right. So, this is to be executed by the computer. So, then how do we understand what a particular software program is doing, right. So, we need to look at software documentation. So, most of the software program they will have their associated software documentation, and what this documentation is likely about. So, describes program function, because when we buy a software and we might not be using the full functionality, might just be using basic functionality quickly, because there is a learning curve that goes with any software. So, right, to be able to learn it better so that more effective use could be done, we need to look at the software documentation, right, and we need to understand the program function and find how this function within the program, within the software, can be better utilized for our business processes, our business needs, or the kind of output that we want, or the kind of processing that we want for our business, right. So, we need to look at these program functions, and therefore, the software documentation is typically provided. So, it describes program functions to operate the computer system or the software, right. Internal source could be there, on screen website, help would be there, then the external source could also be there, printed manuals. So, if it is a complex software, there could be printed manuals, because there could be repeated use due to increased complexity of that particular software. So, people might go for that also, right. And if it is a little bit of help or recall that is needed, then on screen and website support might be sufficient. So, that might also be provided as part of the software program itself. So, that is like internal source, right. Moving on. So, software, bottom line, software a sequence of instructions which might be packing the business logic for the process in the form of codes or in instructions that are executed by the computer. Then, so moving on, next is classification of software. So, classification software, there are two types, system software and the application software. Let us first talk about the system software. So, what is it? So, a set of programs designed to coordinate the activities and function of the hardware resources across the computer system, right. So, when we switch on a computer system and we talked about there would be a bootloader which will know where the operating system is residing, it will load up the or boot up the operating system, and so this bootloader and operating system, these are examples of system software. So, essentially these programs, once the operating system is up and running and we interact with the operating system, and let us say we want to open a word processing software, Microsoft Word, then essentially operating system is providing that that coordination, because that word program would be running or would be using the hardware resources, but how it gets access to the hardware resources? Through a system software, and operating system is an example of that. So, keeping operating system in mind, and then we try to understand this definition, then we get it more easily, that a set of programs. So, all the programs that are part of an operating system, we can take that as an example. So, designed to coordinate the activities and functions of the hardware resources. So, the processing, the memory, the output devices, input devices, all are connected, and the control is with the operating systems. So, right. So, operating system is playing the role of system software and coordinating all this, right. So, designed for a specific GPU and hardware class. So, when we say Windows operating system, so it would be designed for a particular hardware, and if you want to run it on a different set of hardware, then again we need a different installation package if it is available for that particular hardware. So, system software, they are specific to CPU and hardware class, right. If you change the CPU and hardware class, you will have to change the system software, right, because the architecture and the way CPU and hardware works, there might be significant differences which you cannot bypass. So, there is no way but to re-implement the system software for a new, right. So, this is typically referred as porting. So, you have to port the same. If there are some changes, let us say in an operating system, a new version comes up, right, and if you want to have similar functionality for your own operating system that is there in your competitor's operating system. So, you will see that functionality, and if the code is open source, you will look ways to port that code for your new version of your operating system, right. This is referred as porting. Why this porting is needed? Because CPU and hardware class and all that is different. So, you have to figure out how to match or make changes to the code so that it matches the capabilities of your CPU and hardware class. So, that is about system software. Then we come to the application software, right. So, what is application software about? This is a program designed to process computing problems for end users, right. So, system software was about coordinating the hardware resources, right, managing the hardware resources so that the application can run. We talked about a word processing software, right. So, word processing software is an example of a application software, right. So, it mostly resides on the computer's secondary storage, right. So, once it is installed, after that it will be residing in the secondary storage, and when you want to run, you will have to do interactions with your system software. Let us say operating system interface, you will have to interact with the operating system interface to be able to launch that particular application, and that operating system, through your interaction, it will bring the program into memory, and then you can interact with it, and the idea is that it would be designed to process some computing problem for end users, right. So, that is about the application software. Moving on. Now, where do we get or where to obtain these application software or buy these application software, because these are the ones which would be solving all the computing problems that might be there for our organizational information systems part of that. So, the machine element that we talked about within the information system architecture, the basic one, right. So, the application software might be fulfilling the software part of that machine, right. So, there are digital marketplaces, right. So, these digital marketplaces, this is a new change. So, earlier things were different, where organizations used to have CD and DVDs that they used to purchase from the vendors who were selling the software, application software. Now, those days are gone. Now, we are into digital marketplaces, so we can access these digital marketplaces via internet. And what these marketplaces do, they help end users find and download. So, therefore, the transaction cost in terms of finding a software has gone down over the years because of the these digital marketplaces, right. So, you do not have to search and buy and find, get the CD, DVD download, or directly download from internet after lots of search where that website is for that particular vendor, and then getting that download, finding the relevant one and all that. Now, all that is that you have to do, you go to a digital marketplace and there would be a search function there, find and download the relevant software application for their devices, right. So, that some of these digital marketplaces, some of these apps will also do the matching thing for you. So, you might not have to worry about whether a particular app will work in your machine or not, right. So, that matching might also be part of this. So, there is another way to reduce this transaction cost and some of the maintenance like installation cost, right, because of this. So, what are these digital marketplaces examples? So, first one is Play Store, right. So, Play Store is there, that is for Android, Chrome OS, right, Play Store for Android. And so, if you are running Android smartphone or any other Android handheld devices or Chrome OS, Chrome notebook, right. So, you can just access Play Store to get the relevant applications for your device, right. Similarly, App Store is there, which is for iOS, iPad OS and Mac OS. So, the previous one, Play Store, is actually a Google's ecosystem, right. This is a Google's ecosystem, right, whether we are talking about the smartphones or the handheld devices or the notebooks. So, this is Google's ecosystem. And then the App Store that we are talking about, this is Apple's ecosystem, right. So, you can see iOS for iPhone, iPad OS for iPad, and Mac OS for Mac PCs, right. So, if you are having iPhone or iPad or Mac OS, those kind of devices, then you can use App Store to find your useful application for your devices. Similarly, if you are into desktop workstations kind of world, then you have the Microsoft ecosystem here, Microsoft ecosystem, and there is a Microsoft Store. This is for Windows OS and Xbox OS, right. So, if you are having a Windows PC or a PC running Windows operating system or laptop or notebook, right, or you have a Xbox which will have a lightweight version of Windows, right. So, you can access Microsoft Store to find the relevant applications or the game or the content, right. Now, what about the Linux? So, there is a for Linux OS, if you are having Linux OS in your desktop or workstation, right, then there are repository servers by developers. So, there are lots of repository servers maintained by developers for different Linux versions, and so you can access the relevant packages from there. So, the functionality, this is not really a digital marketplace. So, this is not a digital marketplace, only these three, Play Store, App Store and Microsoft Store, are the marketplaces. Linux OS, I have just placed it here for completeness, but there are actually repository servers maintained by the developers for Linux OS. So, that was about the application software and marketplaces. Now, moving on. Now, here the examples that we talked about, so we touched upon the operating system. So, operating system, as I said, example of system software. So, what are these? Android and Chrome OS. So, these are Google's operating system, for what? For smartphones, handheld devices and Chromebooks. So, right. So, Android for smartphones and handheld devices, and Chrome OS for the Chromebooks. So, these are operating systems. So, an operating system is an example of system software as we talked about. And similarly, iOS, iPad OS and Mac OS. So these are Apple's operating system, and these are for iPhone, which are smartphones, and iPad tablets, and then the Mac PCs, right. So again, examples of system software in a Apple ecosystem. Similarly, Windows and Xbox OS, these are Microsoft's operating system, examples of system software for PCs in general having Windows operating system and Xbox consoles, right. So moving on. Now next category of software is web delivered software or web service, right. So we are users of lots of web services or web apps, right. So they will come under this category, web delivered software. So here part of the computing is, it might be happening at the other end, and that is why you will, if you look at the definition that I mentioned here, a program designed to follow server client architecture. So in case of web delivered software, there is a server client architecture that we follow. So it's not just one machine where you have the self-contained unit of that software installed, and whatever functionality is there that is in the software, once installed, it uses your computing resources to run, and you can use that benefit from that application. But in case of server client architectures, two machines contributing to the computing role. This is referred to as server client architecture. So server machine is the one which will be running the web service, which would be running the major chunk of application logic and the needed hardware resource at its end, right. So there would be a server machine, there would be client machine. So two machines, and some computing will happen here and hardware resources would be used. Bit of computing will happen at the client side. So this is a client and this is server, and there is a network in between. So a bit of computing will happen at the client side and bit of hardware resources would be used, right. So this server client architecture, the earlier ones that we talked about, where we could just have the self-contained unit of that software, whether we talk about system software, application software, just one machine, and we get the software installed here, and then we interact with that software and use that. So just one machine. So we are moving from one machine setup to two machine setup, and that this two machine setup is server client architecture. So client machine is the end user's machine, and the server is the provider's machine, the organization which is providing that web service, right. So they are running a server to be able to cater to number of end users. So web delivered software in essence is a program designed to follow server client architecture in combining the web server's hardware resources with those of the client PCs, because bit of computing will happen here and bit of computing. So all this computing, both of it is being used, right, in this process by the web service, right. So and then what is the idea? Idea is to process and deliver valuable computing services. So some valuable computing services are being delivered from the server side to the client side. Server side from some service provider, which might be an organization, an enterprise, and the client side could be an end user, maybe organization's employee himself, or supplier, partner, consumer, or maybe a normal regular user. So valuable computing services to end users, and how? Via web app interface. So we'll be installing a web app which on your client PC, your device and user's device, it will look like a self-contained unit, but it is actually connecting to a server, right. It is connecting to a server, and much of the computing is happening at this place, at the server side. So and then the results are coming back to the client machine, and then client machine is doing a bit of computing so that you can get the results or maybe interact with the output that you, or the service output that you got from the server side. So this is therefore overall I hope you understood, there is another category, that is web delivered software or web service, program designed to follow server client architecture in combining web servers hardware resources with those of client PC resources, and then to process and deliver valuable computing services to end users via web app interface, which could be a web browser, right. This interface could be a web browser on your client PC, so you will be opening a web browser, or if you are having a smartphone, then you might open an app, right. So, when you open Gmail or YouTube, you are watching the video on YouTube, but the content is there in the Google server. So, it is the Google server which is rendering that video content for you, which is coming from the server, right, coming from the server to your machine, and then your machine, the browser or the app is just playing it out. So, that is also client machine is also doing a bit of computing in that process. Okay, so this was about web delivered software category. Then moving on, another interesting concept is to understand all this that we have discussed till now is look at the sphere of influence, right. So, information technology and the associated sphere influence to better understand what we have just talked about in terms of especially in terms of application software. So, there are three sphere of influence that we can conceptualize. One is single user, that we see in practice rather, single user, work group, or enterprise, right. So, there might be applications which are being used by the single user and they benefit, and then there might be certain applications which cater to a work group, or the people which are working on the same thing, maybe a team, not a team, we can say work group, and then the enterprise. So, lots of people connected to the enterprise, they will be interacting with that particular application. So, essentially these are three different things, these three sphere of influence are there, and that has a bearing on the way application software are designed and used and consumed, right. So, let us look at some of these aspects. So, first one is information technology for a single user, right. So, in case of information technology for a single user, the application software it will assist single users in achieving personal productivity and quality at work, right. So, without that application, that single user will be slightly less productive, might take more time, and the quality of the output might also go down. When you use that application, then your productivity improves, you are able to do more work, and the quality of work is is much better. For example, writing a news article for a online news publisher, and if you do that on a paper and then somebody types that out, then there might be few words which might get lost in that process, right. But if you yourself can use a Microsoft Word and type your news piece, and then that is just checked and verified, so the quality improves, faster publication of the article can happen, right, instead of using the paper mechanism first and then digitization of that later, right. So, essentially if you are able to use some of these applications, for example Microsoft Word for writing your piece, right, writing your article, then you see that productivity improves, right, and the quality also improves for that particular single user, and then benefit is transferred to the enterprise organization as well. So, sphere of influence is single user and the gains are productivity gains, right. So, these are some of these applications, that is why they are referred to as personal productivity software. Examples: smartphone, single use, right, makes you better coordinate, receive calls, timely reply to things as a professional, as an executive. Smartphone come in that, Google Calendar, manage your schedules and all that, notifications. Then Microsoft Word already talked about, writing a article and being more productive and more higher quality output you can manage, right. So, moving on, next is the second sphere of influence that we can talk about is information technology for work group, right. So, what happens in this case, some application software, they can support work groups in achieving shared work, shared work objectives. So, the work group might be working for some business process, some business activity for an organization. So, the we are talking about the information technology and the hardware and software which will be supporting this shared work objective and which might be happening collaboratively, right. For example, server, right. The server would be catering to all the members of that work group at least, or maybe to the whole enterprise, but it can cater just to a work group, because they might be working on a particular business process activity, and only in that activity that service that is hosted on that server is being consumed. So, a server, OneDrive, you can share files, so that is another example, or Google Drive, you can share files, OneDrive, and then email to be able to communicate among the team and or receive complaints or messages or requests, right, or different kind of services that you might be providing or giving support. So, through email that communication can happen, right. So, achieving shared work objectives collaborative. So, these are some of the examples where in sphere of influence is a work group, right. So, this is another example. Moving on, the next sphere of influence is like the enterprise. So, there are certain application software or the enterprise software which will cater to this sphere of influence or explain this particular sphere of influence. So, what happens here, information technology for enterprise, it facilitates interaction within and outside the enterprise. So, there might be certain business activities process which need interactions within enterprise and outside enterprise. Maybe anybody can interact, not just a work group or a single user, we are talking about the whole enterprise. So, all the employees, all the and other related suppliers, stakeholders, consumers, clients, they might interact with that particular application, or that and also on the hardware that is supporting that application, right. So, example is web server, some web service is being hosted, right. So, interaction, somebody when you are talking about YouTube, somebody is managing the server, the video sharing service at the Google side. We take the example of YouTube, and the users are uploading their content. So, users are interacting with that same software, and someone is uploading, right, and others are watching. So, there are so many interactions that are happening, right. ERP, enterprise software. So, for employees, so ERP would be hosted on a server, right. ERP would be hosted on a server, and all the employees and other stakeholders would be interacting with the ERP. Similarly, e-commerce app, right. So, there would be a web server that would be hosting the e-commerce app, and the consumers and the sellers who are having their catalog or items in the e-commerce website, they will also be interacting, suppliers and the other ecosystem partners like logistic provider and the employees of the company or the tech team, they all would be using all that this. So, therefore, in this sphere of influence, it is that that particular information system or particular application, the core application that is there, it is facilitating interaction within and outside the enterprise. So, a sphere of influence is at the enterprise level. So, let us stop at this point, and we will continue our discussion in the next session. Thank you.